Okay, so we're going to do an open circuit voltage test now on this PV system. Okay, it's all isolated. I know it's safe to work on. Okay, this system has 2 strings, one of 5 panels, one of 8 panels. I need to do a test on each system. It's an open circuit voltage test on each set of panels to make sure that they're all connected together and that they are actually working. Okay, so on the back of your panel, you'll see there's a data plate. If I put it up the right way, we might have a bit of a chance. You can see open circuit voltage, 36.85 volts. 5 of those panels added together, we just add the volts together. So it's going to give me around 185 volts. 8 panels west, again, 8 times whatever the open circuit voltage is going to give me an expectation of 295 volts. We know that these panels are all tested under standard test conditions so that when you buy them, you know what you're getting for your money. There's no fiddling from the manufacturers. Standard test conditions means that the panels are hit with 1,000 watts of sunlight at a temperature of 25 degrees. Okay, that's standard test conditions. These outside now, my panels are just sat on the roof. They could be a bit dusty. Maybe the sun's not as bright as it should be. It's a bit gloomy. So I'm not expecting those values, but I'm expecting something close. So what I need to do is just disconnect my strings. And you can see here, look, I've got the string with 5 panels on. The positive is marked with a red wrap. The negative is marked with a white wrap. When I've got my 8 panels, I put 2 wraps on. Okay, that's so that I can just identify them and they don't get muddled up. If you go to a job and you're doing some remedial work and you see that the leads are marked brown and grey, grey would be the negative, that's the old system, okay? If you look on page 179, you'll see now that the table tells you for non-earthed DC systems, we want red for positive and white for negative. Okay, so now I'm going to do the test. I've got a PV test clamp meter here. You can see it's Mega. You guys that have seen me before doing these tests know that I use Mega all the time because I know it's reliable. I know their safety standards are far above most other manufacturers, okay? And I want to be safe when I'm testing because a lot of this stuff is live. We know we're not supposed to test live, but on PV, you've got no choice. In daylight, those panels are live, so we're working live. That makes us more careful, okay? So what I do, I plug these in to the ends of the strings, and that's going to measure my voltage. But before we start, just to make life a little bit easier for yourself, if you look at an MC4 connector, you can see here, there's 2 little tags that clip. They lock in to the female side of the connector. They're a job to get apart and you need a special tool in some cases. Me, I've cut those connectors, those tags off, look, okay? That means that when I plug them together like so, once I've done the test, I can just pull them apart. That's not the case if you don't cut those tags off. Okay, so anyway, here we go. I choose the 5 panel array first, put the ends in, set it to PV voltage, and I'm looking for a value of 185. I know I'm not going to get that. I've got 163. That's working, tells me it's working fine. You can see by just what happened just now. The sun's gone in a bit, it's going to have a little effect on it. So 163 is fine, that's acceptable. I know they're all connected together properly. So I turn this off, disconnect it, and now we'll do the 8 panel array. Again, whoops, getting in the right old state here, look. Here we go. Connect the ends together, put it to PV voltage. I'm now expecting 290 volts, but it's not going to give me that, is it? Because it's a bit gloomy. I've got 266. Fine. I know the system is all linked together properly. I can now proceed on to my other tests, which are insulation resistance and short circuit. I need to do the insulation resistance. I need to do this open circuit voltage test first before I do the insulation resistance, because obviously if there was a break in the cable, I'd only be doing half the test. So we know now we can safely move on, and we're going to do the test properly.